So, good morning students, I am Krina Dayani and I am your chemistry teacher. In our previous lecture, we have discussed about the different models of an atom. First model we have discussed about the Thomson model. Second model we have is Rutherford's atomic model. And yesterday we have discussed about the Rutherford's atomic model. Firstly, we will do a quick revision for the Rutherford's atomic model. So, Rutherford's atomic model. In Rutherford's atomic model, what we have seen is, firstly, the atoms will revolve around a prescribed. In Rutherford's atomic model, what we have learned is, from the Rutherford's gold foil alpha scattering experiment, he have observed that most of the space in an atom is empty. The entire positive charge is located at the center of the nucleus, and in that valence shell, the electrons will keep revolving. So, he gave some of the postulates regarding the atomic theory which was not proved by Sir J.J. Thomson. Now, there are also some drawbacks in the Rutherford's atomic theory. We will going to discuss about the Rutherford's drawback. Now we will discuss the drawbacks of Rutherford's model. So, first point is, Rutherford would not be able to explain the position of electron in a particular shell. He did not explain that how many electrons will be accommodated in one shell. So, the first drawback in the Rutherford's atomic model is it did not tell us about the number of electrons in a shell. So, Rutherford would not able to explain about the valence electrons in a particular shell. And second point about the Rutherford's atomic model is that it did not follow the concept of electromagnetic theory. So, what actually the electromagnetic theory is? Rutherford's model will not follow the electromagnetic theory. According to the electromagnetic theory, if something is revolved around a certain charge in the atom, suppose we have positive charge concentrated at the center of the atom and electron keep revolving around the nucleus. So, according to electromagnetic theory, there is a continuous emission of radiations from the particle and the speed of the electron will slow down and electron will fall into the nucleus, but this would not happen and the theory is discarded. So, according to this theory, what actually is going to happen here is, in the center we have a positive charged nucleus, and what happens here is electrons keep revolving in the outermost shell. Here electrons are revolving. So, according to electromagnetic theory, if a certain amount of charge is revolving around another charge, there is a continuous loss of energy or emission of radiations from this particle. It means there should be emission of radiations. If a negative charge is accelerated or revolve around the positive charge, there must be the emission of radiations between these particles, and because of that emission, the speed of the electron must be slowed down. So what will happen next? speed of electron should be slow down. So if speed of the electron will slow down, then after a certain period of time, this electron must be fall into that nucleus. If the speed of the electron will slow down, electron will fall into nucleus. But these three conditions would not happen in the Rutherford's experiment. So Rutherford would not be able to explain the electromagnetic theory of radiations. So this point is discarded by other co-scientists. Now, what will be the third drawback of the Rutherford's atomic model? The Rutherford's atomic model firstly could not tell us about the number of electrons in the particular shell. It would not able to explain the electromagnetic theory. Thirdly, if there is a continuous emission of radiations, the spectrum should be continuous. So, it should have continuous spectrum. But what actually happen if a spectrum is observed in the emission of the radiation of these particles? There is a definite level of discrete frequencies of radiations which could not happen. But what actually we get? There is a discrete frequency levels. So the spectrum should be continuous. In spite of that, we will get the discrete frequency levels like this, the frequency at F1, F2. So this point is also not proved by the Rutherford. So these are actually the three drawbacks in the Rutherford's atomic model which was discarded, and after that Bohr gave us its model and it is known as the Bohr's atomic model. So it is all about the drawbacks of Rutherford's atomic model. Now we will continue with our fourth model, that is our last model, and it is the Bohr's atomic model. If someone wants to copy it, please copy it now. Now after three models, we are on our last model in the structure of atom, that is Bohr's atomic model. So our next topic is Bohr's atomic model. As we see in the Rutherford's atomic model, nucleus is centralized at the center and electrons will keep on revolving. So sometimes Rutherford's atomic model is also known as planetary model. Rutherford's model is also known as planetary model. Now we are on our next topic, that is Bohr's atomic model. What actually the drawbacks that will be overcome by the Bohr? First point Bohr say about the particles is an atom usually consists of three subatomic particles, that is proton, electron and neutron. So first point is atom consists of three subatomic particles. So these three subatomic particles are electron, proton and neutron. These are the three subatomic particles of an atom. He called first particle is electron, second is proton and third one is neutron. After that, Bohr gave its second postulate that the entire mass of the nucleus will be the sum of protons and neutrons. So, the second point is nucleus is equal to sum of protons and neutrons. It means protons will have a positive charge and neutrons will not carry any of the charge. So, the entire mass of the nucleus is only due to the positive charge. So, protons will having a positive charge, neutrons will having a no charge. So, entire mass of the nucleus is only due to the positive charge. Entire mass of the nucleus is only due to the positive charge. If I considered atom here, over here, we see that the entire positive mass will be concentrated at the center of the atom, and this positive charge is known as nucleus. Now, next point Bose say about the atomic model is that the entire positive charge will be concentrated at the center of the atom and the negative charge will keep on revolving around it. So, if we consider negative charge will keep on revolving in an orbit. Third point is negative charge revolves in a particular path. If negative charge revolves in a particular path, we will call that path as a shell or an orbit. So, this path is called orbit. So, electrons revolves in a prescribed path and this path is actually known as orbit, or sometimes we call it as shell, and electrons are the charges of negative energy. Now, next point of the Bohr's atomic model is that if the electron revolves in a certain path, it will have a shells, and we can name these shells as K, L, M, N, O and so on. Sometimes we also name the shells as 1, 2, 3, 4, 5 and so on. So, shells can be identified as K, L, M, N, and the particular shell will consist of a fixed number of electrons, and the formula for calculating the number of electrons in a particular shell is 2n square. By having a 2n square, we can calculate the number of electrons in a particular shell. If I draw a nucleus at a center, see here, we can locate the nucleus at the center, which is the entire mass of positive charge here. This is nucleus, and we have the particular electrons in a particular shell here. So, first shell is K, second one is L, third is M and fourth is N. We can also identify this as 1, 2, 3, 4. So, the maximum capacity of an electron can be calculated by the formula, that is 2n square. Now, we will calculate the number of shells. We can write the K as K, L, M and N. We can write it as first energy shell, it is second, it is third energy shell and it is fourth energy shell. So, energy shells can be identified as first, second, third, fourth, and it is indicated as K, L, M and N. Now we have to calculate the number of electrons in K, L, M, N. So we have shell and number of electrons here. We have 4 shells, K, L, M, N, and the value for K is 1, for L it is 2, for M it is 3, and N it is 4, and it is number of electrons will be calculated by the formula, that is 2n square. So 2 into 1 square, what we will get here, the number of electrons is 2. Now 2 into 2 square, what we will get 8 electrons. 2 into 3 square, what we will get 18, and 2 into 4 square, we will get 32. So in K shell we have only 2 electrons, in L we have 8, in M we have 18 electrons, and the 32 electrons will be accommodated by N shell. So the number of electrons in a particular shell is fixed. So for K it is 2, for L it is 8, for M shell it is 18, and for N shell it is 32. So the number of electrons in a particular shell will be fixed. Now we come to the next postulate of the Bohr's atomic model. What will be the next postulate? The next postulate for the Bohr's atomic model is that the energy will be absorbed or released when the electron jumps from lower to higher or higher to lower. So the fourth postulate of the Bohr's atomic model is that energy absorption or emission when electron jumps. Suppose we have a shell over here. This is the lower ground state and this is the uppermost shell. Again we have lower state and here it is a uppermost shell. Now what we will see here, suppose we have an electron in the ground state. This is electron in the ground state and the electron will jump from lower energy state to a higher energy state. So this is lower energy state and this is higher energy state. So what we are seeing here, an electron is jumping from lower energy state to a higher energy state. So if electron jumps from lower to higher, it needs a certain amount of energy. So here the absorption of energy take place. Energy will be absorbed. So in our next category, we have suppose electron in an highermost shell. This is lower energy state and this is higher energy state, and electron will going to jump from higher state to lower state. If electron jumps from higher to lower, then there will be the emission of radiations. So energy is emitted here. So we can say that energy will be emitted in the form of h nu, and h nu will be equal to E1 minus E2. So it is the fourth postulate of the Bohr's atomic model that when electron jumps from lower to higher or higher to lower, there will be the absorption of energy. If the electron keeps revolving in the same shell, there will be no change in the energy. It means if the electron is in same shell, there will be no change in energy. If it goes from lower to higher, there will be the absorption of energy. If it comes from higher to lower, there will be the emission of energy. So, it is all about the fourth postulate of the Bohr. Now, we are on the fifth postulate of the Bohr's atomic model. That what fifth postulate is. Fifth postulate of the Bohr's atomic model. The fifth postulate of the Bohr's atomic model is that the angular momentum will be equal to we have nucleus at the center and there are the electrons revolving around the nucleus. The next postulate is we see that the entire positive charge is centralized at the center of the atom and the electron will keep on revolving in the negative part, and what we will see that there must be a force of attraction between these two particles. So if there is a force of attraction between these particles, this force is actually balanced by the centrifugal force of the electron. So next postulate is force of attraction between electron and proton will be equal to centrifugal force. Now, proceeding to our next postulates about the Bohr's atomic model, we see that electron will revolve in a certain orbit. So, the angular momentum of that electron will be the integral multiple of nh upon 2 pi. So, the next postulate of the Bohr's atomic model is that angular momentum is a integral multiple of h upon 2 pi. It means electron revolving in a particular orbit having an angular momentum in an order of n. So, angular momentum is a multiplication of mass, velocity and radius, and we have a formula for angular momentum that is equal to mvr. So, here m is mass of electron, r equal to radius and v equal to velocity of electron. So, here is a formula for angular momentum. If I considered a positive charge nucleus here and electrons revolving in different orbits, then the angular momentum of that electron will be the integral multiple of h upon 2 pi. It means mvr is equal to nh upon 2 pi. Here h is a Planck's constant. H is equal to Planck's constant and the value for this Planck's constant will be 6.25 into 10 raised to the power minus 34 joule second. So, here it is a value of h upon 2 pi. Pi is 22 upon 7, or we can consider 3.14 for solving the numerical problem. If I consider the first shell, it must be equal to h upon 2 pi. If I talk about the second shell, it must be 2h upon 2 pi. So for first shell, it is h upon 2 pi. For second shell, it is equal to 2h upon 2 pi. So it will come as an integral multiple as h upon 2 pi, 2h upon 2 pi, 3h upon 2 pi, and so on. So angular momentum for an electron will be the integral multiple of nh upon 2 pi. Its value will be in the integral multiple, not in the fractional multiple. So here are the basic postulates of the Bohr's atomic model, which are accepted worldwide, and no other theory came after this to discard these points. So until now we have discussed about the 4 atomic models, that is firstly Dalton's atomic theory, second is J.J. Thomson's atomic model, that is basically known as plum pudding model. On our third discussion, we have discussed about Rutherford's atomic model, and the fourth one is Bohr's atomic model. So now this lecture is over for today. We will start our next topic in our next lecture. Thank you so much and have a nice day.